Okay, so now once again we'll quickly revise what exactly the map, and then we'll see how to implement the map interface, right? Is it visible to everyone? Is it visible or not? Okay, fine. So a map is an object that maps keys to the values, right? So it is also one way of representing a collection of elements together, represent it as a single group, right? So always the key should be unique in the map interface, right? It won't allow you for the duplicate key, right? You can keep a map to at most one value. Okay, so it depends upon the mathematical function. As you are aware of that, in hashing, we need to define a function. With that function, we'll try to generate the key. Using that key, we will try to map the elements. Okay, so the same kind of the same implementation here also, right? So the map can be implemented using three different classes. One is hash map, tree map, and linked hash map. So as if you don't bother about the ordering of the elements which are present in the collection, you can go with the hash map, which is more efficient when compared with remaining two. If you are not worried about ordering, but if your consideration is ordering, okay, so then you can go with the linked hash map or tree map. So in the linked hash map, it follows the ordering process of insertion order, whatever the order that they arrived, okay, they keep maintains that order, and the elements will be represented in that order only. Whereas in the tree map, it follows the tree structure. It follows the tree structure where that is binary search tree structure, where the root node should be greater than the left child and less than the right child. So that kind of mechanism it follows in the tree map. Okay, so now let us look at about the implementation part of this particular map interface. As you all aware of that, there are various places which we are using these maps, especially the dictionary. We look at about the word. Suppose if you want to search for a word advance, okay, always you just try to look at the key of alphabet A, because it starts at A. Okay, so in such a way, there are so many examples which we have discussed in the last class where we are supposed to use this map interface, right? Now let us look at about the various methods which are available in which we have discussed in the last class. Okay, now we will see the implementation part of all these things with an example. Okay, right. Okay. So this is a simple example of creating a map using a map interface using a hash map. Of course, we'll see tree map and as well as linked hash map representation also, right? So here I was created an object M for the class hash map, which allows the two objects. Here you can observe that two arguments. One is for representing the data and another one is for representing the keyword. Here my intention is I want to find out how many times the word is repeated in a given sentence. So this program is meant for counting the number of word in a sentence. All right. So for that, the string represents the word and the integer represents the key. Okay. So now initializing the frequency table from the command line. That means you can give your arguments at command prompt, so that this program itself, it calculates the number of occurrences of the word in a given string. Okay, for string A of args in the sense which we are accepting from the command line, whatever the string that we have accepted from the command line. Okay, so from that we'll extract the string, and into the frequency is equals to m dot get A. How many number of times it was repeated in that will be calculated using this, and m dot put A of A. Here you can observe that frequency is equals to null, it is 1. Otherwise frequency plus 1. That means if it is the first time the occurrence of initially the occurrence of that word, we don't have any information regarding that frequency. Frequency in the sense previous number of occurrences in it. Now initially it is null. Whenever if it was occurred first time, that will be assigned with the value 1. Next time if the same word is appeared in the sentence, it gets incremented. That means the frequency plus 1. Initially the frequency value is 1. Now it becomes 2 when it was appeared in the second time. Okay, like that it is going to be calculated. Okay, so and finally it was displayed size comma. So let us check it out. This is the statement or the sentence which was supplied as an input. Welcome to BDA class section 2. Something we'll try to give the similar words so that the count will be increased. SEC2 BDA, BDA. Okay, so this is the sentence which I was applied. Now what we are expecting from this input is how many times the BDA was repeated? 1, 2, 3, 4. So BDA count should be 4 and section 2 count should be 2, and the word 2 count should be 1, 2, 3. Okay, and welcome count should be 1. So let us see whether it produces the same output or not. Yeah. So the section 2 is repeated 2 times, 2 is repeated 3 times, welcome is repeated 1 time, and class is repeated 1 time, whereas BDA is repeated 4 times. Whether it is correct or not, you can check it out from the input given by us. Okay. So here what we have to observe is for each and every one, we are supposed to assign a key and as well as the value. Here the key is whatever the count that we are going to use, and the value is the word, the distinct word. Okay, so in such a way we will calculate, we'll see the how this map is going to be, map interface is going to map the key value phase, right? We'll see another example of the same map interface, how it is going to be implemented with the help of linked hash map. So once again, we will try to execute, because here I was taken the output. Here I was taken 3 different words. Suppose if you try to execute these 3 programs simultaneously, so that you can understand the difference of outputs, how this hash map and tree map are executed. So once again, I'll execute the hash implementation of map interface with a different program. Right here I was created again the same way map object, and I was entered the values are map.put is equal to Vishal 10, 3 different words followed by the keys I was entered, and I would like to print those values. Okay, with the help of these particular get key and get value methods, as we have discussed in the slides itself. Get key, which is used to get the key, get value, which is used to get the value. Whereas entry set is the set which contains the whole elements of the map. Okay, so from that set, then that means all the elements which you have entered entered will be treated as an entry set where you will find all the elements. From that, we will try to get the key value and as well as, sorry, we'll try to get the key and as well as value of those things. Suppose if we execute the same program here, we have entered three different ways. So you can observe the output what we are expecting is 130-20. Instead of 130-20, you are getting 20-10-30. Because whatever the order that you have entered, if you get the similar, then it is okay. But here you get the different order. So that's why I told you hash map implementation does not bother about the ordering. Just it will print the in a random way. Okay. So that is the reason you may not get the same order whatever the way that you have entered. So if you want to get such kind of ordering, insertion order, we are supposed to implement the same with the help of linked hash map. So now let us see a linked hash map representation of the same algorithm, the same program, how it is going to be generate the output. Don't worry, I'll share all these documents with you so you can execute at your home. If you have any queries, you can ask. Same program with the help of linked hash map. Just only the class name only it is going to be changed. Linked hash map. In the previous case, just simply only hash map. Now it is linked hash map. Nothing has changed. Remaining code as usual. 10, 30, 20 as the order which you have entered. Now execute this program. So now you can observe whatever the order that you have entered here itself, you got the output in the same order. So as I told you, in the linked hash map representation, some ordering will be followed. The ordering mechanism is whatever the order that they entered into the collection, the same order it maintains. So you can check it out whether it is correct or not also. So first we have entered Vishal 10. Now the same is printed as first one. Similarly, Sachin 30 is entered as the second element. The same you got as an output. And third Vaibhav 20. So in this way you can implement it. And the third one is tree map. So just simply change this. Now you can observe 30, 20, 10. What is it? As I told you, binary search tree mechanism. Left child should be less than the root and the right child should be greater than the root. Now in our case, by applying that phenomena, so the 20 becomes root and 10 becomes the left node and 30 becomes the right node. So right root, left is the traversing process. So that's why here you got the output as 30, 20, 10. So this is the difference between different kinds of implementations of map interface. In all the cases, they just simply key value pairs. So just it is an object which maps keys into the values. That's it. Set mapping. Okay. So along with sets, we can also use the maps for representing the collection elements also. Okay. So that is about the collections. Now let us look at about the important aspect of generic classes and generic methods. Right? Is it visible to everyone? Any one of you? Visible or not? Okay. Okay. Now, generics. Generics is similar to templates in C++. You might have experience in C++ where usually when you define a method with a particular data type arguments, always it insists us to supply the same information. Okay, what happens in that case? Yeah, you can ask. Yeah, H3, you can ask a question. H3. H3. You raised your hand. If you have any query, you can ask by unmute yourself. Or otherwise, I'll continue. Please let me know whether you have a doubt or not. H3, are you there or not?
No, sir, nothing.
Okay, okay, okay. Right. So, whenever if you want to supply a different arguments each and every time when you run the program with a different data type elements, so in that case, whatever the standard mechanism which we are following is unable to handle. So that's why people have developed a mechanism in C++ in the form of templates where you can decide what type of data you want to supply to the method as an argument during the runtime. So that is what we are called as generalization. So the same method can be used for any data type, not to a specific data type. Same class can represent any data type rather than this predefined. I mean, predefined in the sense, while declaring the class, if you specify the data types of the data members, that is here my intention of predefined. Okay, so you need not specify the type of the data which the class is going to represent or which the method is going to handle. Okay, these things you need not worry at the time of defining your program. You can decide at the time of running your application. You can specify what type of data you want to supply as an input. So this mechanism is called as generalization. Will make everything as most generic. Okay, so in C++, we'll implement the mechanism with the help of templates. So here we'll have generics. So generics in the sense, you can define your generic class and you can define your generic method by following certain rules and regulations. Now let us see how to implement what exactly the generics and what is the generic class and what is generic methods and how it is going to be implemented. These things we'll discuss now. Okay, so the idea, as I told you, the idea is allow you different types to be parameters to the methods, classes, and interface during runtime. Okay, for example, in the classes like hash, array set, hash map, we are using the generics. You can observe the program itself also, where I'll show you. So here you can observe string and integer. Okay, string and integer. So the specification of this type is also called as generic. You might have a doubt, sir. You told me that you can decide at runtime, but here it was already defined. Don't worry, we'll see those implementations also. Okay, so okay. So to create an instance of generic class, okay, you are supposed to follow this syntax as we have observed in the previous example. Base type, and this type specifies the data type of the object. Okay, and here it is obj represents the name of the object and new base type and followed by the type. Okay, so here these are the some of the alphabets which we are used for our convention in implementing generics in Java. So T specifies type, E specifies elements, K specifies key, and N specifies number, and V specifies the value. Whenever if you observe these individual alphabets in capital letters, okay, you can think that you can imagine at your brain like T represents type, E represents element, K represents key, N represents number, and V represents value. Okay. Now, so what is the advantage of implementing generics in Java? So the first one is code reuse. As I told you, suppose if you develop a program for addition of two numbers, Okay, usually what we have to do, you need to specify the data type of the two numbers which you are going to be added. For example, if they are integer, okay, you just write the code return a plus b. For example, int a and int b are the two parameters. Those are the numbers. If you want to add those two, what you have to write? You just write the method int add within the brackets int a comma int b. Because here the return type of the method is integer and the name of the method is add, and the arguments which are supplied to that function is a and b. Both of them are integer type. So in that in the code, in the definition of the function, what you are supposed to write? Return of a plus b. That means whatever the value that it obtained after adding the a plus and b, after adding a and b, so those that value will be returned as a return value. So this is the code for implementing addition of two numbers. Suppose in our case, if we define it as a generic method, okay, each and every time, suppose you may pass floating values as an arguments, you can pass double values as an arguments, you can pass integer values as an arguments, like that. Whatever the other data types that it was supported by Java, so those all the arguments you can supply each and every time when you're running the program. In such a way also you can define. So that means what happens in that case? Writing the same code, single code, and which can be used for different purposes, without rewriting, without any modification of the method which you have developed. So that is the reason code reuse is one of the important advantage of implementing generics. And another one is type safety. As you are aware of the typecasting, whenever if you are converting one data type into another data type, okay, if you did that process by writing the statement, okay, is called as typecasting. Typecasting, okay. Float b is equals to float of int a. What happens in that case? The variable a is going to be converted into float data type, and that will be stored in b. Okay, so whenever if you want to convert from one type to another type, you need to write the typecasting mechanism. But with the generics, you need not write any kind of typecasting mechanism. Automatically, system will take care of converting one data type to another data type. Because as I told you, if when we implement the addition of two numbers, first time if you may supply floating point values, next time you may supply double values, next time you supply integer values. But initially, we have developed the code for handling only addition of two integers. Okay, am I clear or not? So in that case, each and every time when you are changing the type of the parameters that we have supplied to the code, okay, in all the cases we require a typecasting process. But with the help of generics, we need not worry about typecasting process. It will automatically take care. So you just have to write this paragraph. Generics make errors to appear compile time rather than at runtime. Okay. So suppose if you want to create an array list, store the names of the students. If by mistake the programmer adds an integer object instead of string, compiler allows it, but when we retrieve this data from the array list, it causes the problems if you are not defined it using generics. If you define it in a way, and if you do this particular mistake while handling array list, you will get a runtime error, because array list anyway it will allow you the element, but the array list is defined for the purpose of storing only in string values. But instead of string value, if you store integer value, it raises an runtime error. So in order to avoid all these things, we'll try to use generics. All right, and individual typecasting is not needed. Okay, if we do not use generics, then every time we retrieve data from array list, we have to typecast it. That means while retrieving the data from the array list, if you want to change this type to some other, what happens in that case? We need to write the typecasting procedure for each and every time when you retrieve every element from the array list. So actually it is a very difficult task, and even it is a burden on us. Okay, instead of doing all these things, we'll implement the generics. Of course, anyway, if you know what type of data that is present in the array list, and if you write the operations based on that data, then no issue. But whenever, unfortunately, if you store any different data, I mean, if you store the string data and if you try to perform operations like addition and subtraction on those strings, okay, as the way which you perform it on integers, it is a difficulty task. Okay, right. And implementing generic algorithms. So by using generics, we can implement most generalized application where we can do all the operations. For addition, say for example, if we define addition of numbers, addition of two numbers, okay, so that method is used for adding any type of integers, any type of integers. Okay, so in such a way you can write a most generalized algorithm which can be suitable for many kinds of data. So these are the advantages of generics. Now let us look at about the representation and the definition of generic class, and then we'll go for generic methods. A generic class declaration look like a non-generic class declaration. So usually what we observed in the class declaration, a class may contains data numbers and member functions, right? So it is also similar to that, same kind of declaration, except that the class name is followed by the type parameter section. Along with the class, you can observe here public class, generic class is the name. Okay, usually ordinary class is ends here itself, but when it is generic class, you need to specify the type parameter. Here you can observe T in the uh, angular brackets, right? Okay. We can define our own classes with a generic type. Okay, a generic type is a class or interface that is parameterized over types. Here you can observe that it is parameterized over types. So here in this method, whatever the class data type that I have specified for T, the same will be applicable for all the methods which are defined in the class. Say for example, here I was defining the T value as int. What happens in that case? This item will be considered as item variable will be considered as integer type and will display the same value. Suppose if it is string, the item becomes string value. Okay, suppose if it is float, or if it is another object type, yes, it will. So here you can observe that usually in the class generic classes, it won't allow you to define the primitive types like int, float and all. We will see in the example what happens if we define like that. Usually it is used for representing different types of objects as a type parameters. Okay. Notice that the use of generic type class in the main method, we need not do typecasting, and we can remove class exception at runtime. Okay, if we are not following the generic mechanism, we are supposed to write the statements class cast exemption. Okay, this kind of error may be occurred while running the program, as I told you in the previous slide. Array list, which is defined for holding string values. Unfortunately, if the programmer adds integer value to that, it raises an error message during the runtime, which I was told in the previous slide today. Okay, so that error is called as class cast exception. So this error is occurred during runtime. Okay, if we do not provide the type at the time of creation, the compiler will produce a warning that generic type is a raw type. So you need to be, if you forget to define the type of, during the declaration, it raises this error message. Okay, references to generic type should be parameterized. Okay, so definitely you should reference any one of the type. So, okay, without referencing this type, simply if you write generic type, if you write the class name as generic type, here if you forgot this, okay, what happens in that case? It leads to a problem. Okay, when we do not provide the type, of course, sometimes by default it will be taken as an object. The type becomes object, and hence it's allowing both string and integer objects. But we should, but it is good practice that you need to specify what type of data you want to supply as a parameter. Don't leave it as an empty. Okay, right. So this we have discussed. Okay. Before going to discuss about the generic methods, we'll look at the implementation of generic class with a simple example. Yeah, this is an example. Yeah, it's some error setting. Last test somewhere it was. Yeah. So this is a simple implementation of a generic class. So now you can observe that class name is test and followed by the generic parameter t. Okay, and here you have one data member and as well as a constructor test t obj. This is also a generic method, because wherever if you specify the data type of a parameter is generic, that method becomes generic method. So here this constructor is also a generic method because it references the generic type. Okay, so this dot obj is equal to, this is the constructor, and this is another method which uses the generic type for returning the object. Okay, now in the main program you can observe test integer. Here I was supplied as integer value. Okay, test uh, integer object is equals to new test of integer. Here I was supplied the element as 15. Okay, system dot out dot println of iobj dot get object. That means whatever the value that you have supplied will be stored in the object of this particular class, and the same will be displayed with the help of this particular statement. Similarly, test string. In the previous case, we have supplied integer as a data type for this t. Now, instead of integer value, we are going to supply string as data type for this t. Okay, and I was supplied welcome to sir CRR COE as a value. Okay, if you execute the program, you got the output 15 for the first time, and second time welcome to sir CRR COE. So here what you are supposed to observe is, here we have supplied two different types without changing even single line of code. Initially we have supplied integer value, and then we have supplied as a string value as a parameter. So writing the programs in this way is called as implementing generics in Java. So similarly, you can use, here we have observed, this is a generic method and this is generic class. Okay, like that you can specify, you can pass your own objects. That means whatever the other classes that you have created in the program, and the objects of those classes are also be supplied as an input to this generic class also. So it depends upon your requirement, you can go ahead. But here you need to remember an important point is, in the generics in the sense whether it is generic class or generic method, you can supply your own type as an argument to the class and as well as method. So that is the important point here you need to be remembered. Okay. Now let us see the generic method implementation, generic method, and then we'll go to the implementation part of generic method. Yeah, generic methods. We can write a single generic method declaration that can be called with arguments of different types based on the, okay. So as we have discussed in the constructor part of the test class, that there you can supply your own type. So we can write a single generic method declaration that can be called with arguments of different types. So you have defined the program for adding integer numbers, but later you have changed your decision and you want to supply floating point values as the parameters to it. So in that case, without modifying the code, you can reuse the same code for handling floating data also. So based on the types of the arguments passed to the argument method, the compiler handles each method call appropriately. That means each and every time when you are supplying different types, compiler will take care of, as I told you, typecasting and all things will be taken care by the compiler. So based on that call, based on the parameters which you have supplied, okay, automatically it can handle. But you need to follow the following rule guidelines for handling the while writing the generic methods. So all the generic method declarations have a type parameter section. As I told you, while declaring the generic class also, you need to specify the type parameter section. That is, as we have observed in the test, followed by T within the angle brackets is called as a type parameter section. Okay, so the same should be done with the in the generic method implementation also. Okay, so delimited by angle brackets that precedes the method's return type. Suppose if you want to return any value from your method, you can specify the type of that data which you want to return. Suppose if it is void, you can write void, right? So so definitely you have to specify either void or any other data type which the function is going to be returned. As you know, it is. Each type parameter section contains one or more type parameters separated by commas. So sometimes you want to supply two different data types as an arguments. One is integer and one is string. In that case, T followed by, T1. T1 represents the integer and T2 represents the string. For example, T1 object 1, comma, T2 object 2. Where T1 represents the integer value, T2 represents the string value. Of course, we'll see in the example. Okay, in such a way, whatever the number of types you want to pass, just simply you can pass but you need to separate one with another with a comma. So a type parameter also known as type variable as an identifier that specifies the generic type name, as you are aware of that. And the type parameters can be used to declare the return type and acts as placeholders for the type of the arguments passed to the generic method, which are known as actual type arguments. Suppose you have returned an integer value. Okay, that means what this particular statement, the meaning of this statement is, you can also use the return type as the type parameters. Okay, not only for inputting the parameters to the method, you can also use the return values also as type parameter. And last point, a generic method's body is declared like that of any other method, that means normal method. Note that type parameters can represent only reference types, not primitive types like int, double, and char. Okay, so whatever the data type that you have supplied, that it is going to be represented, right? So this is about generic methods. Now let us see the implementation part of generic methods. See, before going to discuss about the generic method, let us see how to pass a different arguments, different in the sense more than one type parameter as an input to the So are you able to see this screen? Is it visible or not? Otherwise, I'll share it once again. Any one of you? Is it visible or not? Okay, done. Yeah. So here you can observe that in the previous case, in the previous example, we have supplied only one type. But now here in this case, we are going to supply two different types. As I told you, any number of parameters types can be specified as an argument, but you need to separate one with another with commas. So here I have supplied two different parameters. One is of type T and another one is of type U. So the object here I was declared two objects. One is of type of the T type and object 2 is of type U. Okay. So you just try to understand the difference between the previous example and this one. Here we'll pass two parameters, two type parameters, whereas in the previous one we'll supply only one. That is only the difference, nothing else. Right? So the T, this dot object 1 is equals to obj 1 and this dot object 2 is equals to obj 2. Here in this case, this obj 1, the T acts as a data type of this particular object 1 and U acts as a data type of object 2. Okay. So the same will be assigned to the objects which are created. Simply here you can observe that string comma integer obj, in that case the first one T will be represented with the string data type and the second one U will be represented with the integer, because whatever the order that you have specified, the same will be assigned. Suppose in this case string is assigned to T because this is the first one in the list and this is the first one in this list. So that's why string will be assigned to T and integer will be assigned to U. Okay. Now the object 1 is acts as the string data type and object 2 is acts as a integer data type. So whatever the values that you have supplied for those objects, the same will be printed here itself. Okay. So in such a way, you can pass any number of parameters as the type parameters, but each and every one should be separated with a commas. Okay. So that is about how to pass multiple parameters. So the similar way for the methods also, no issue. Any number of parameters you can pass. So now let us see the implementation of generic method. Yeah. So this is the implementation of generic method. So in the generic method, what we are supposed to observe, for the method, we are able to pass multiple, different types of data types as an argument. Okay. So those will be represented as. So in this case, you can observe that public static E void print array E of input array. E stands for element. As I told you, some of the shortcuts are the alphabets which are used to represent the different words. Okay. For E dot element input array, system dot out dot printf, the element is going to be printed. Now here the important point is, don't worry about the definition and of all these things. Here our intention is what way we can pass different types as a parameters to the method. So now here integer int array, where we will supply 1 2 3 4 5 as the elements, and then we have declared double array and it was initialized with different, like that, one character array. So now we have three different arrays. So let us see system.out.println print array of, here print array is the method name, and here I was supplied int array. So the first array, that is collection of integer elements, this was supplied as an element. So E will be replaced with int array, and the next case E will be replaced with double array, and third in this case the E will be replaced with character array. So each and every time we are supplying different argument. First time we have supplied integer array, second time we have supplied double array, third time we have supplied character array without modifying anything. Here we did not change even single line of code while passing different parameters, different data types as an argument. Okay, so that is the important point here itself. Don't worry about for what purpose we have defined this method and all, because it depends upon your requirement. You can write any method, but here our intention is Zoom open chesava. ఏం చెయ్యి నెట్ ఆఫ్ సరిపోవట్లేదు అది నెట్ ఆఫ్. So is it visible to everyone? Because I'm facing some problem. Now it is visible to everyone or not? Am I audible? Okay. Sorry. I got a message like you are signed right now, signed out like that. I got a message. So that's why I was verified once again. Okay. So now in this example, what we are supposed to understand is each and every time you can pass different data types without modifying the definition of the generic observe execution of this program. We generate the outputs. Yeah. So you can observe first time when we are calling the print array with the int array by supplying integer array as an argument, so it displays the all the integer elements 1, 2, 3, 4, 5 which we have supplied, which we have stored in the integer array. Similarly, double array. Similarly, character array. So without changing the code of the generic method, you are able to pass different types of arguments. So that is about generic methods. Of course, don't worry about all these things. While implementing big data applications, we exclusively use only generic methods and generic classes in many of the situations. So there we will see one in detail once again the importance of these methods. Right? Hope you all understood generic classes and generic methods. So now, if you have any queries, you can ask. G4, do you have any query? G4, you have any query? Okay. So, okay, I'll end the session now, and we will discuss the remaining topics in the tomorrow's session. Okay, thank you.